Welcome. Now we're going to identify the vertex. So we'll start with standard form, and then vertex form, and then intercept form. So identifying the vertex algebraically in standard form. So first of all, if your equation is not in standard form and you want to use this method, you're going to have to make sure your equation is in standard form. Right? So we want f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. By the way, if there was no c, no constant, and it was ax squared plus bx, that would still be standard form. It just means our c is 0. All right, so we need to identify the vertex with point hk. H stands for the x-coordinate of the vertex. K stands for the y-coordinate of the vertex. We're not going to be able to identify it from the equation itself, but we have a handy-dandy little formula that we could use to identify the x-coordinate. To identify the x-coordinate, you're going to take the value of b, make it the opposite, just like in quadratic formula, right? The opposite, negative b, and then you're going to divide it by 2a, just like a quadratic formula. That will give you the x-coordinate. You have a choice for finding k, the y-coordinate. And I should have both ways in your notes. Okay, so method number 1, to find k, you can simply substitute h, your x value, into the equation and solve for k, your y value. And that's perfectly fine. We also have another way, which is to find another way to find k, and that's using a formula here. You notice parts of it look a little bit like quadratic formula, or the discriminant. Actually, it's the discriminant, but the opposite, and then divided by 4a. So kind of looks like the discriminant, kind of looks like quadratic formula. But it'll give you the y-coordinate of your vertex. K equals negative, and then it's the opposite of the whole expression there, b squared minus 4ac, all divided by 4a. There is a third way to find the y-coordinate. Actually, let me talk about the second way for a moment. So why would you want to use that formula instead of just plugging in? Well, maybe you don't want to plug in your h value. Maybe it's a fraction. Maybe it's a really large number. Maybe you're like, I don't really want to plug it back in. So if you don't want to plug it back in, then you can use this formula for k. And I'll show you a problem where we're going to decide to use that formula. Whether you plug it back in or you use the formula is completely up to you. Our third way of finding the y-coordinate is something called synthetic substitution, using the x-coordinate of the vertex. We'll talk about that in another lesson. And actually, it will be during the next series of lessons. So nothing with graphing quadratics, but in the series of lessons that follows, we'll talk about substitution. For now, you have two methods. So it's either plug it back in or use our formula here. All right, so let's take a look at this equation. So we have f of x equals 2x squared plus 8x plus 6. So our a is 2, our b is 8, and our c is 6. Right? So to find the x-coordinate, I do need to use the formula h is equal to negative b divided by 2a. And then we'll simplify as much as possible. So our h is going to be negative 8. I just take the opposite of 8. And then I'm going to divide by 2 times 2. All right, so that's going to give us, actually maybe I'll just keep writing across. That looks like n. Negative 8 divided by 4, which is negative 2. That's the x-coordinate of our vertex. Right? So now negative 2, that's a pretty small number. That's not very difficult to work with. I'm probably going to opt to plug it in. For this example, I'll use both methods. In the future, if it's pretty easy to plug in, I'm just going to plug it back in. And if I don't want to plug it back in, I'll use the formula. All right, so here we're going to find f of negative 2. So we have 2 times negative 2 squared plus 8 times negative 2 plus 6. Right, and I'm not going to write f of negative 2 again. We'll just put equals. Equals, we got to square first. So negative 2 squared is 4. So we have 2 times 4. And I can do the multiplication at the same time here. 8 times negative 2, that's minus 16 plus 6. So I have 8 minus 16 plus 6. So 8 minus 16, that's negative 8. Negative 8 plus 6 is negative 2. Let's do the same thing, but we'll use this formula k. Let's see if we get negative 2 again. So k is equal to, and so by the way, let me just put a k equals. So k equals negative 2. Come on. Oh, there it is. All right, so k equals, so we have the opposite. B was 8, so 8 squared minus 4 times 2 times 6. Don't forget to close your parentheses there, because all of that, right, is going to be the opposite, and then divided by 4 times 2. All right, so that's 8 squared. My square is almost in my negatives, in my equal sign, or in my negative sign. That looks like almost like an equals, but that's, my square is just kind of drifting. So we have negative 8 squared is going to be 64. And then minus 4 times 2 is 8, and 8 times 6 is 48. All divided by 8. So that's going to be negative 64 minus 48, that's 16. So negative 16 divided by 8, that's negative 2. So you see we got the same thing both ways. So it does not matter to me which method you use, right, to find the y-coordinate, but I offer you 2 methods, so you have a choice. So the vertex for this particular equation is the point negative 2, negative 2. Right? Our x-coordinate, h, was negative 2, and our y-coordinate, k, was also negative 2. It won't always be the same. It just is the same for this one. Let's take a look at another equation in standard form. And here's one where I really would like to use that k equation. So if I take negative b divided by 2a, right, so my a is 4, my equation is y equals 4x squared plus 2x plus 13. So my a is 4, my b is 2, and my c is 13. So h is going to equal to negative b divided by 2a. So I'm going to plug in a 2. So I have negative 2 divided by 2 times a is 4, so 2 times 4. That's negative 2/8 or negative 1/4. Now maybe you don't want to plug back in negative 1/4 and have to get, add fractions and get common denominators and all of that. You won't have to worry about that. So this is one where I'd really rather use the k equation, right? So I call it the k equation, even though both methods give me k, but here I'm using a special equation to find it as opposed to the equation of our function. So here we have k is equal to negative, and then b squared minus 4ac, so it's just like quadratic formula on the inside, and then divided by 4a. All right, so k is going to be equal to negative 2 squared minus 4 times 13, all divided by 4 times 4, which would give us negative 4. I need my parentheses there. Negative 4 minus, I don't have a calculator anywhere nearby me, 16 times 13. Oh, wait, I can reach one. I could just do this a little faster by plugging into a calculator. Or otherwise, well, you know what? I can do 16 times 13 in my head. I can do that. So 16 times 13 would be the same as 16 times 10 plus 16 times 3. I'm too lazy to get the calculator. And this isn't too difficult, so it would be 160 plus 48. So it's 208. You can check my math for me. And if I made a mistake, let me know. Maybe I'll check it after this podcast. All right, so we have negative 4 minus 208, all divided by, and that is 16. So that's going to give us negative 204 divided by 16, and now we'll just reduce that. All right, so the two negatives, that's going to become a positive, right? And then, should do that. And then 204 and 16, they're both divisible by 4. and that's because 200 is, and 4 is just 204 is just one more 4. So 4 will go into 204 51 times, that's prime, and 4 will go into 16 4 times. So our answer is 51/4, that's our k value. So our vertex, where am I going to write it? Over, I guess over here. The vertex for this particular parabola is the point -1/4, 51/4. Right? So this is an example of a time where I didn't really want to plug back in. So there are two methods to find k, the y-coordinate of the vertex. You pick whichever one you like. Usually I just plug in, unless I have a fraction that I don't really want to plug in. And here, this is one I didn't really want to. And you can just do it this way using the k formula. All right. Let's look, so standard form, so by the way, standard form, that was a lot of work, right, to find the vertex. Right? I had to find the x-coordinate and the y-coordinate. Let's look at vertex form. All right, so identifying the vertex algebraically in vertex form. Y equals a times x minus h squared plus k. The vertex is the point hk. So let's look at this equation, the equation we found the y-intercept for. F of x equals 2 times x plus 2 squared minus 2. In vertex form, the h represents the x-coordinate of the vertex, and the k represents the y-coordinate of the vertex. So the vertex can be easily identified as hk when the equation is written in vertex form. Now just be careful. See the negative. Don't say the vertex is 2, -2, because you would be wrong. Right? So another way I can write this is 2 times x minus a -2 squared minus 2. Right? Minus a negative is the same as plus. And I don't know what's up with that too. So remember, the negative has to stay with the equation. It's part of the equation. So when we plugged in -2, right, minus a -2, that becomes a plus. So this plus is equal to minus a -2, and our vertex is the point -2, -2. I think I've heard that point somewhere. I don't remember where. So in vertex form, the h, remember, is the x-coordinate, and the k is the y-coordinate. Just remember, the sign's going to be the opposite for the h, right, because there's already a negative there. Later on, later on we're going to be graphing some functions using what's called translations. And that includes quadratic functions as well. Right now we won't be using this method, but later on we will. So I thought, since we're talking about vertex form, and for long we'll be graphing using translations, I would talk about that in relation to vertex form, because it's really easy to see which way our graph might go from the equation when it's in vertex form. So a problem with the vertex at the origin is y equals x squared. That's called a parent function. That just means it's like the most boring, basic parabola I could come up with, right? X and y intercepts, it's the origin, right? And it's right in the middle of the graph. Right? So it's the most boring function I can come up with, most basic parabola. Right? It has nothing done to the x squared. These rules apply to all functions. We'll talk about them now with the vertex form of our quadratic equations, and then we'll talk about them and use them more in graphs to come in the future. So rules apply to all functions, and so not just parabola, although I'm talking about parabola right here. So we have an x minus h. That causes the parabola to shift horizontally to the right. The minus is always with the equation itself. And that'll be true for every single graph that we look at. We have that minus is always there. And I'll talk about why a little later on. Right? So x plus h makes our parabola shift horizontally to the left, because that means we added a negative value. It's minus a negative. Right? So here the x minus h, that's positive, right? Because the minus was already there, right? And so h is a positive number. It's going to go to the right. When we have a plus h, it means we have minus a negative, so we move to the left. If we add something, it shifts our parabola up. If we subtract something, it shifts it down. This is true for all of our parabolas, whether it's in vertex form, standard form, or intercept form. If our a value is greater than 1, it's going to stretch the graph vertically. It's going to get skinnier. If a is between 0 and 1, it shrinks the graph vertically. It gets fatter. Right? So if you multiply something greater than 1, you're going to get larger and larger numbers. But if you multiply something between 0 and 1, so you take half of something, well, a half of something is less than a whole something, right? It's going to grow slower, and so the graph gets fatter. A negative a always reflects the graph across the x-axis. It's going to be concave down. So I have over, if you notice, on the right-hand side there, the axis of symmetry for this graph is x equals negative 2. We'll talk more about the axis of symmetry, but it is a vertical line that goes right through the vertex, right? And so it's going to be equal to, it's always, oops, what happened to my x? It's always going to be equal to, come on, go away. No, I had to put the marker down. It's always going to be equal to x equals h. Right? So here, h is negative 2. The axis of symmetry is negative 2. Back here, for this graph here, the axis of symmetry, I'll put it over here. That would be x equals negative 1/4. Right? So it's just a vertical line that goes right through the vertex. Right? So vertical line is always x equals, so that's why it's the x coordinate. Vertical lines have x-intercepts, no y-intercepts. Let's look at the last one, finding the vertex, and that is for, oh, whoops, we're going to skip. Oh, we'll do this one. Sorry. We'll do a few more, and then we'll look at a little bit more with vertex form, and then we'll look at our last method. So let's identify our vertex here just to show you how easy cheesy lemon squeezy it is. We're going to identify the vertex of these 4 functions here. Right, so remember, the negative goes with the equation. So this is really x minus a negative 4. Right, so that means, right, so this part right here, that's x minus a negative 4. That means our vertex is the point negative 4, negative 2. Right, so you're just going to make this x one here, that one's the opposite. Right, because the negative goes with the equation. This one, the number added in, the y-coordinate, that's the same. And there was no negative added in. On the next one, our vertex. All right, so we already have x minus. That means that number right there, that's the x-coordinate. And this number right here, that's the y-coordinate. 4, 2, that's the vertex. So remember all that work we had to do when the equation was in standard form. We don't have to do any work here. Right? So we already know that x plus 4, that's the same as x minus a negative. Oops, that was supposed to be a 4, not an x. So that means our vertex is the point negative 4, 2. And that's all there is to that one. And one last one. Right? So here we already have a minus. Our vertex, leave the minus behind, just take the 4. So 4 and this whole thing there, that's the y-coordinate, negative 2. So just remember, make the, I'm going to move it over because it's a little crowded over here. Because the negative goes with the equation, for the x minus h part, oops, goes with, I was trying to write the word equation. Negative goes with the equation. So you're going to make h the opposite, but k you keep k the same. And that's all there is to find the vertex in vertex form. Easy cheesy, lemon squeezy. Let's look at our last one. Oh, sorry, I forgot. We're going to look at the different graphs and the vertexes. Then we're going to look at our last one. So we're going to identify the vertex algebraically in vertex form. The vertex is the point HK, right? So here we can see that this one, if we want to write in vertex form, because technically it's a standard form, y equals x squared, this would be y is equal to x minus 0 squared plus 0, right? Writing in zeros, how boring. So that means our vertex is the point 0, 0, right there, right? And then we'll talk about how the points change on this graph and how the points will change as we're trying to graph. Right, so there we have our boring little parabola, y equals x squared. What if we changed it from y equals x squared to y equals, let's go down, 2x squared, right? So we're going to look at this one here, y equals 2x squared. Well, this would still have the same format in vertex form, x minus 0 squared plus 0. So the vertex here is still 0, 0. But notice we have a coefficient in front of x squared. That's making our graph grow faster. So notice we had on the first graph, we had the point 1, 1. On the second graph, we have the point 1, 2. Our graph is growing twice as fast. Right, so we multiply by 2, we have a vertical stretch. The graph grows twice as fast. Right, because of that 2. Otherwise, it's situated in the same location for the vertex, but it's not going to look the same as y equals x squared, right? Because it's growing faster, it's going to be a skinnier graph. Let's look at the next one. Right, so here we have y equals 2 times x plus 2 squared. So now we've replaced the x with an x plus 2. That's the same as y equals 2 times x minus a negative 2 squared. So that means we're going to shift 2 to the left, right? Because h is negative. Our vertex is the point negative 2, 0, right? Because we have to change that plus to minus and negative, because the minus has to stay with the x. So our h is negative 2. And there's nothing added in, right? So it's negative 2, 0. What if, besides just replacing the x with an x plus 2, we also subtract 3? Well, then our graph is going to shift down 3 units. Right? So now, on the last one here, we have y equals 2x. That's got to be minus a negative. And then we have, if we can squeeze it in, a minus 3. So now our vertex is going to be the point negative 2, negative 3. Our graph is shifted. So notice this is the same looking graph as y equals 2x squared, but it's in a different location. Right? So first it's been shifted 2 to the left, so our vertex is at negative 2, 0. Then it's been shifted 2 to the left and shifted down 3. So now our vertex is at negative 2, negative 3. Okay? We're going to be working with graphing using our vertex, our x and y intercepts. In the future, though, we'll also use something called transformations to graph quadratic formulas. And so here I just gave you a little exposure to it as we're looking at the vertexes of our equations in vertex form. So now let's look at the very last one. We want to identify the vertex algebraically in intercept form. So in vertex form, no work. Standard form, kind of a lot of work. Intercept form is right in between. Right? So the vertex, the y-coordinate of the vertex, the x-coordinate of the vertex, you're going to find by taking your two x-intercepts. So p and q, those are the x-intercepts. X minus p and x minus q are the factors. So if I have x minus p equals 0, if I want to find the x-intercept, right, we just take our factors, set them equal to 0, and then solve for x. So the two factors are x minus p and x minus q. The x-intercept, we take x minus p, set it equal to 0. So x equals p, that's an x-intercept. If we set the second x minus q equal to 0, we'd have x equals q as the second x-intercept. Notice that now when we solve for x, the p and q are both positive. The negative stays with the formula, just like vertex form. All right, so to find our x-coordinate of the vertex, the h, all you have to do is take the average of the two x-intercepts. Right? So you just add the p and the q together, divide by 2. That's your x-intercept. To find the k, the value of the function for that particular value of h, all you have to do is plug in. You will have to plug in here. I don't have any special formula. However, it's really easy because you're just adding and multiplying. It's not like you have to, even if you had a fraction, it's not even as hard as standard form. I'm not squaring. I'm just, when it's all factored out nice for me, I just have to multiply the two numbers together. And by the way, never change intercept form to vertex form. Intercept form to standard form. Intercept form is so much nicer. I'll take a little extra work on the y-intercept over all the extra work standard form gives me. If it's already in standard form, we're stuck with it. Otherwise, let's just work with an intercept form, because intercept form is really nice. All right, so to find h, all I have to do, I don't care about the 2, right? It's just when I just take the x-intercepts. X plus 3 equal to 0. So x is negative 3. That's one x-intercept. X plus 1 is 0. X equals negative 1 is the other x-intercept. I add those two together, divide by 2. So h is equal to negative 4 divided by 2, which is negative 2. To find k, we're just going to plug in. I'm going to move this over because I'm going to move this way over here. Oh, I didn't think it'd break up. We'll move it piece by piece. Oops, the negative 3 goes here. Watch all the pieces move. This way I have a little bit more space for us to find k. All right, so we take f of negative 2. We have 2 times negative 2 plus 3 times negative 2 plus 1. Well, that's pretty easy because we just have 2 times negative 2 plus 3, that's 1. Negative 2 plus 1, that's negative 1. So 2 times 1 is 2, times negative 1, that's negative 2. And so that means that our vertex is the point negative 2, negative 2. Boy, it's a popular, we had a popular popular y-intercept, now we have a popular vertex. Right? So I do believe that's the last thing on vertex form I have. Oh, I have axis of symmetry. Almost forgot. Let's do axis of symmetry, and then I'll see you in the next podcast for the x-intercepts. All right, so the vertex lies on the axis of symmetry. The axis of symmetry divides the parabola in half and is a vertical line through the vertex. You should have this in your notes, right? Right in your notes. In any format, the axis of symmetry is a vertical line at x equals h. We talked about that when we looked at the vertex form. So where h is the coordinate of the vertex. So your axis of symmetry goes right through the vertex, divides it in half. It's nice to know where your axis of symmetry is and to graph your axis of symmetry when we're graphing, because we'll be able to find points using our axis of symmetry, right? Because it has to be symmetric on both sides. That's why it's called the axis of symmetry, right? It's not called the axis of asymmetrical. It's called the axis of symmetry. So the right side looks like the left side. So if you got a point to the right, you got to have the same point to the left. That's what's nice about the axis of symmetry. Right? So in the last equation, our axis of symmetry, of course, was the equation x equals negative 2, because it's tied to that value, the x-coordinate of the vertex. I'll write that a little nicer, and then I'll see you in the next podcast. Bye for now.